power steering systems. The power steering unit is designed to reduce the amount of effort required to turn the steering wheel. It also reduces driver fatigue on long drives, and makes it easier to steer the vehicle at slow road speeds, particularly during parking. There are several power steering systems in use on passenger cars and light-duty trucks. The most common ones are the external piston linkage, integral piston, and power-assisted rack and pinion system. External piston linkage system. The external piston linkage system, sometimes called non-integral, is generally found on older cars. It consists of a power steering pump and reservoir, control valve, power cylinder, and 4 hoses. The control valves and pressure cylinders are separate components that are not incorporated into the steering gear. The pressure hose connects the pump to the control valve and directs the pressurized fluid into the correct booster hoses to the power cylinder. The power cylinder piston provides the necessary power assistance. Integral piston system. The integral piston system is one of the most common conventional power steering systems in use today. It consists of a power steering pump and reservoir, power steering pressure and return hose, and steering gear. The power cylinder and the control valve are in the same housing as the steering gear. On some recent model cars and light trucks, instead of the conventional vacuum assist brake booster, the hydraulic fluid from the power steering pump is also used to actuate the brake booster. This brake system is called the hydro boost system. Power assisted rack and pinion system. The power assisted rack and pinion system is similar to the integral system because the power cylinder and the control valve are in the same housing. The rack housing acts as the cylinder, and the power piston is part of the rack. Control valve location is in the pinion housing. Turning the steering wheel moves the valve, directing pressure to either end of the back piston. The system utilizes a pressure hose from the pump to the control valve housing, and a return line to the pump reservoir. This type of steering system is common in front-wheel drive vehicles. Components. Several of the manual steering parts described earlier, such as the steering linkage, are used in conventional power steering systems. The components that have been added for power steering provide the hydraulic power that drives the system. They are the power steering pump, flow control, pressure relief valves, reservoir, spool valves, and power pistons, hydraulic hose lines, and gearbox, or assist assembly on a linkage. Power steering pump. The steering pump is used to develop hydraulic flow, which provides the force needed to operate the steering gear. The pump is belt-driven from the engine crankshaft, providing flow anytime the engine is running. It is usually mounted near the front of the engine. The pump assembly includes a reservoir and an internal flow control valve. The drive pulley is normally pressed onto the pump's shaft. There are 4 general types of power steering pumps: roller, vane, slipper, and gear. Functionally, all pumps operate in the same basic manner. Hydraulic fluid for the power steering pump is stored in a reservoir. Fluid is routed to and from the pump by hoses and lines. Excessive pressure is controlled by a relief valve. Flow control and pressure relief valves. A pressure relief valve controls the pressure output from the pump. This valve is necessary because of the variations in engine RPM and the need for consistent steering ability in all ranges from idle to highway speeds. It is positioned in a chamber that is exposed to pump outlet pressure at one end and supply hose pressure at the other. A spring is used at the supply pressure end to help maintain a balance. As the fluid leaves the pump rotor, it passes the end of the flow control valve and is forced through an orifice that causes a slight drop in pressure. This reduced pressure aided by the springs, holds the flow control valve in the closed position. All pump flow is sent to the steering gear. When engine speed increases, the pump can deliver more flow than is required to operate the system. Since the outlet orifice restricts the amount of fluid leaving the pump, the difference in pressure at the two ends of the valve becomes greater, until pump outlet pressure overcomes the combined force of supply line pressure and spring force. The valve is pushed down against the spring, opening a passage that returns the excess flow back to inlet side of the pump. A spring and ball contained inside the flow control valve are used to relieve pump outlet pressure. This is done to protect the system from damage due to excessive pressure when the steering wheel is held against the stops. Since flow in the system is severely restricted, the pump would continue to build pressure until a hose ruptured or the pump destroyed itself. When outlet pressure reaches a preset level, the pressure relief ball is forces off its seat, creating a greater pressure differential at the two ends of the flow control valve. This allows the flow control valve to open wider, permitting more pump pressure to flow back to the pump inlet, and pressure is held at a safe level.